Okay, let's begin. Now note that whenever the limit of a function is tending to a real number, always add the constant 0.001 to the real number is tending to and store it as x in the calculator. Very, very important. So take note of this point. Okay, let's look at the examples I have here and solve them together. Example 1 here says, evaluate the limit x tending to 4, where we have the numerator values to be x squared minus x minus 12, and the denominator values to be x minus 4. So right now, let's bring the calculator to solve this problem together. Okay, the first thing we're going to do will be to clear the calculator. Very, very important. The essence of clearing the calculator is to avoid unnecessary error, because you might not remember whether you have performed a previous calculation on the calculator. So to clear your doubts and to be at the safe side, you are advised to clear your calculator. And to do that, you simply press Shift button 9 and follow the instruction. We want to clear all, press 3 and press equal to again. So we have cleared the calculator. The next thing we are going to do now will be to add 0.001 to this 4 and store the value as x in the calculator. So let's do it. That's 4 plus 0.001. So we're going to store this value. If you like, I can change it to a decimal value like this. So we are going to store this value now as x in the calculator. To do that, you simply press Shift. This RCL button stands for store, then the S button. So once you do it, it will indicate here that this value answer has been stored as x in the calculator. So you wipe this. So what we're going to do now will be to impute these values we have here in the calculator. So it's in fraction. Let's go. So we have x squared there. To bring out x in the calculator, you press alpha first before pressing x. So you press alpha x. If you just press x alone without pressing alpha, x will not come out unless you press alpha first before pressing x. So take note of this point. So we have x squared minus x alpha x minus 12 all over x alpha x minus 4. So that's it. We are done. Let's now press equal to and see what we are going to get as an answer. So let's change this value into a decimal value. We press SD. So we have 7.001 as an answer. 7.001. So you cannot approximate this value. So automatically our answer is 7, which is option D. It's as simple as that. Okay, let's solve example 2 together. Okay, example 2 here says, evaluate the limit x tending to 1, where we have the numerator values to be x cubed minus 1 and the denominator values to be s minus 1. So right now, what we are going to do now will be to clear the calculator, because we are going to store a new value in the calculator, which is 1. So let's clear the calculator, which is we press Shift button 9 and follow the instruction 3 equal to again. So we have cleared the calculator. So let's add 0.001 to this one and store the value we get as x in the calculator. So we have 1 plus 0.001 is equal to So let's store this value as x. To store, you press shift this RCL button and the alphabet X. So once you do it, you will see here indicating that this value has been stored as X in the calculator. So you wipe it. So right now let's impute the values we have here as the question in the calculator. So it's in fraction, we have x cubed, which is alpha x. You make use of this power button and come down -1 all over x minus 1, which is alpha x minus 1. So let's press equal to. So we have 3.003001. So this value cannot be approximated. So automatically our answer is correct, which is option D. So it's as simple as that. Very, very easy. Just follow the steps I've shown you and solve any similar question you are given. You will definitely get the right answer. So right now we are going to solve a different version of this kind of question. Okay, example 2 here says evaluate the limit x tending to pi, where we have the numerator value to be tan x over the denominator value, which is sine 2x. So right now let's bring the calculator and solve this problem together. Okay, as usual, the first thing we are going to do will be to clear the calculator to avoid unnecessary error, because we're going to store a new value in the calculator. So to do that, you press shift button 9 and follow the instruction 3 equal to again. So right now we are going to add, before we add 0.001 to pi, we have to put our calculator in reduce mode because of these trigonometric signs we have here. So we will not solve this question with the calculator being degree. We have to change it in reduce to get the correct answer. As to put your calculator in reduce mode, you simply press shift mode button. Category 4 is reduce. You press 4. So it's now in reduce. Right now, let's go ahead and store the value of 0.001 plus pi in the calculator. So let's go. We have 0.001 plus pi. To bring up pi, we press shift. Pi is here, this button. So that's the press equal to. So let's store this value as x in the calculator. To store, you press shift store this S button. So once you do it, it will indicate here that this value has been stored as x in the calculator. So let's wipe it and impute the question in the calculator. So we have here tan x, which is tan s alpha x. We close the brackets all over sine 2x. So we have sine 2x alpha x. We close the brackets. So that's what we have there. So right now let's press equal and see what we get as an answer. 0.5. So 0.5 is the same thing as 1 over 2. So our answer to this question is option C, which is 1 over 2. It's as simple as that. So this is basically how you can solve limits of a function tending to a real number with Casio calculator. Is as simple as that. Just make sure you add the constant 0.001 to any real number the limit is tending to and use it to evaluate or substitute the question. It's very, very simple. We are going to look at how to identify a continuous, discontinuous and removable discontinuous limit. The limit of a function is said to be continuous when the value of x in substitution to equation is defined, while the limit of a function is said to be discontinuous when the value of x in substitution to a question is undefined. The limit of a function is said to be removable discontinuous when the value of x in substitution to a question is 0. Now, having known these basic definitions, let's look at the example we have under this slide and solve it together. So after solving, our answer will help us to know whether this is a continuous or discontinuous or removable discontinuous limit. So let's solve this together. Okay. So what I'm going to do now is to use this value of s, which is square root of 5. So I'm going to use it to evaluate this expression. That when you store the value of x square root of 5 to substitute this x square here and use it to evaluate this expression, the answer we get after our evaluation will tell us whether this is a continuous or discontinuous or removable discontinuous limit. Okay, so let's go. Before I do or perform any calculation on this calculator, always make sure that you clear your calculator. The essence of clearing this calculator is to avoid unnecessary error, because you might not remember whether you have stored a previous value in this calculator before. So to clear your doubts, if you're not sure, to clear your doubts, make sure you clear the calculator whenever you want to use it to perform a new calculation. Just make sure you clear the calculator to avoid unnecessary error, right? Okay, so to clear the calculator, what we do is to press Shift button 9, clear, follow the instruction. We want to clear all, so we press 3 and follow the instruction equal to yes and press equal to again. The calculator has been cleared. So now let's go on and store square root of 5 as x in this calculator. So we start by pressing square root of 5. Then to store it, you press Shift store x. So this arrow sign indicates that this value, square root of 5, has been stored as x in this calculator. So we wipe it and impute the question as it is appearing here in the calculator. So it's in fraction. We use this button. So we have 3 all over x squared. Now to bring out x, if you just press x, it will not come out, unless you press alpha first and this button x, it will come out. So we have x squared minus 5. So this is what we have in the question. So let's press record and see what we get as an answer. So we have mass error. So this tells us that this is a discontinuous limit. From our definition, a limit is said to be discontinuous when the value of x in substitution to a question is undefined. Now this mass error is an undefined value, so it is a discontinuous limit. And then we did this and got a definite value, like 2, 3, 1, 5, 5.2, 6.7 in that succession as the case may be, this would have been a continuous limit. Had even we did it and got 0, just 0, no point to the 0, just 0, this would have been a removable discontinuous limit. But since we did it and we didn't get a definite value, neither did we get 0, this is a discontinuous limit, right? So this is basically how you can know when a limit is continuous or discontinuous or removable discontinuous. It's as simple as that, right? So that's it for this class. I believe I explained this topic very well. So if you're new to our channel and you're not yet subscribed to our channel, make sure you hit the subscribe button to subscribe to our channel for more of our videos. Also, like, share, and comment on this video, right? Comment on this video to tell me how you feel about what you have learned in this class. If you seem to have a specific question regarding what I just taught in this class, feel free to leave your question at the comment section below. I will ensure to give you a response.